Okay, so let's look at some problems. A Mercedes-Benz of mass of 1,700 kilograms is parked on a road that rises 15 degrees above the horizontal. What are the magnitudes of the normal force and of the static frictional force that the ground exerts on the tires? Now, when we look at this, we have to draw our free body diagram. The static frictional force points to the right, the normal force points up, and the gravity points down. Now we need to break up our forces on x and y. Now our net force on the y is equal to mass times acceleration, and our net force on the x is equal to mass times acceleration. However, because the car is not moving, we can use the equilibrium concept. So my normal force, which is on the y, minus my mass times acceleration, cosine 15, will be equal to 0. And on the x, it's my static frictional force minus my mass times gravity times sine 15 will be equal to 0. Now you just move everything to the right side to find your normal force and your static frictional force. I'll do the static frictional force as an example. And it will give you that your static frictional force will be equal to 4,300 newtons. Now let's look at number 2. A 6-kilogram box is sliding across the horizontal floor of an elevator. The coefficient of kinetic friction between the box and the floor is 0.360. Determine the kinetic frictional force that the force that acts on the box when the elevator is stationary, accelerating upward with an acceleration of 1.20 and accelerating downward with an acceleration of 1.20 meters per second squared. Now this is simple plugging into the formula. We know that the kinetic force will be equal to the coefficient of kinetic friction times the normal force. So it gives you, when you plug it in and you distribute, you factor out an m, you see that your coefficient of friction times your mass times your gravity plus acceleration will be equal to your kinetic frictional force. So now A, if your object is stationary, then that means that your acceleration will be equal to 0. So when you plug in your values, you see that your kinetic frictional force will be equal to 21.2 newtons. Now let's look at B. You have to use the same kind of formula, same kind of thinking. However, your acceleration will be 1.20. So you'll add that to your G of 9.8. And it will give you 23.8 newtons. Now for C, the common mistake is that since it's accelerating downward, you need to make sure that your acceleration will be negative. So you use the same formula, however, you subtract 1.20 from 9.8, and you see that you will get 18.6 newtons. Let's look at our last problem. An 81-kilogram baseball player slides into second base. The coefficient of kinetic friction between the player and the ground is 0.49. What is the magnitude of the frictional force? And B, if the player comes to rest after 1.6 seconds, what is his initial velocity? Now the magnitude of frictional force is equal to the coefficient of frictional force times the normal force. So using that, we can just plug in simple values and find that your kinetic frictional force will be equal to 389 newtons. Now this will be your force. And for B, you know that you have to use kinematics. So you know that your net force is equal to mass times acceleration. And you already have your force of 389 newtons, and divide that by your mass will give you an acceleration of 4.8 meters per second squared. So you have your acceleration, your V initial. Your V initial is what you're trying to find. Your V final will be 0 because it comes to rest, and your time is 1.6 seconds. So using kinematics, you see that you can plug in the values and find that your V initial will be equal to 7.7 meters per second.